Hello and welcome everyone. Welcome to Azure Community Live. Today we have the second day in a row where we have Alessandro Vozza today. And please let me know if everything works good today, because yesterday we had some technical issues. So please let me know in chat if everything is working correctly, if you can hear me, if you can hear Alessandro, so we can fix things when stuff is not going correctly. Today we're having another session on Kubernetes. Yesterday we had Pascal Naber who explained us everything, the introduction to using Kubernetes and AKS on Azure. And today we have Alessandro Vozza, who works for Microsoft, also a host of the Kubernetes meetup in Amsterdam. So very welcome to have you here. And
Thank you.
well, Alessandro, let's just take it away. Let's get straight into the content. If you could, you're sharing your screen. Let me switch to the content, and then just let's get going.
Perfect. All right, so I'm ready. Can you see the screen?
Yeah, we can see the screen.
All right. So there's a bit of delay on my because I try to keep an eye also on the chat. Anyway, thank you, Gert, for the introduction. So I'm very happy to be here and talk about some of the topics I love the most, which is A, Kubernetes, and B, security, and C, of course, the Azure Kubernetes service. So
yeah, Alessandro, I will take a look at the chat for you. So if there are any questions on the chat, I will forward them to you. I will unmute myself and then go and ask them to you. So you don't have to watch the chat. You can just focus on your slides and present the content.
Okay, great. So hello everybody. My name is Alessandro Vozza. I'm Italian, but I live in Amsterdam for many years. You can find me on Twitter there, and most of the time you can find me on the Kubernetes Slack in the NL user channel, so the Dutch community hangs there. What I am, it's complicated, so to say. So I am an ambassador for the Cloud Native Computing Foundation, which is the foundation that takes care of the Kubernetes project and many other projects. I organize a conference in Amsterdam called Kubernetes Community Days, sponsored by CNCF. I'm a freelancer as well, so that's what my company looks like. It's Lovelace Engineering in memory of Ada Lovelace. And finally, I'm also a full-time employee at Microsoft, and I've been enjoying working with Azure and with Kubernetes for more than 3 years now. So let's dive right away in the topic of today. So I know that Kubernetes is it's a not easy, not too complicated either. I mean, depending on your skills. Yesterday was a great introduction to Kubernetes and to Azure Kubernetes Service by Pascal. You can find the link. You can find it in this YouTube playlist probably. So if you haven't seen it, please go now and watch that. But it was a great introduction to the general Kubernetes concepts and to Azure Kubernetes Service in particular. What we're going to talk today instead is we're going to focus on specific topics about security. So we're going to look at many different things, about 16 topics. I have an hour, so I hope I can make it in time. And I have a few more tips for you at the end. So what it's all about is that it's not enough to have a Kubernetes cluster up and running. What you really need to do is to make it secure, to take care of it, to make sure that that nobody can access it, but only the people intended to. Make sure that it doesn't have security holes. Make sure that it's patched. All these kind of things. So it's a lot of topics. They seem to be disjointed, but in fact they're all aspects of the same thing, which is the holistic security approach to Kubernetes and to AKS. Gonna dive right away into the first one, which is managed identity. Oh, first of all, a disclaimer. Yes, I am an employee of Microsoft, but all the things I'm saying here, they are my my opinion. As always, I mean, of course, like this webinar where we are between friends in a way, so we I can just tell you how it is and the not so great stories about AKS and security, but of course it doesn't represent the official opinion or position of the product team of AKS. So there are many concerns. So once you have a cluster up and running, you have to think of many aspects of security that may not be crossing your mind in the beginning. So for example, if you want to restrict public endpoints, you want to have workloads restricted to specific zones, or you want to dedicate host pools to specific teams, and so on and so forth. There's so much to talk about security, and Kubernetes is just adding more layers to our cloud infrastructure, which means adds more layer to security. So it means that there's a bit more things to consider, a bit more effort to put in. But of course, like the benefits are way more exceeding the effort you put in. I mean, Kubernetes is the de facto standard for container orchestration, for deploying containerized cloud-native applications. So it's worth using, it's worth considering at least, and it's worth, once you decide that this is something that you or your organization can benefit from, it's really worth to dedicate some thoughts to security and to think security in the beginning of the deployment, in the beginning of the adoption of containers and Kubernetes. So I assume that you know what is Kubernetes. I assume that you know what is Azure Kubernetes Service. I assume that you probably know how to run a AKS cluster. It's not really difficult. Pascal explained yesterday. It's really one CLI command away, or a few click in the portal if that's float your boat, or a simple Terraform template away. So it's a native service in Azure, and it's treated as a first party citizen in Azure. So everything I'm going to talk about assumes that you kind of know a bit about how Kubernetes works and how AKS works as well. So the first topic is the managed identity. So every cluster needs an identity. Why does it need an identity? Because it needs to interact with the underlying cloud infrastructure. So the advantage of running Kubernetes in the cloud is exactly this, that whatever goes around Kubernetes, or whatever Kubernetes needs to run your application effectively, think of persistent storage or load balancers, are provided by the cloud. And the way that this happens is through a thing called Cloud Controller. Used to be a core part of Kubernetes, and now there's the cloud controllers. The AWS, the GCP, the Azure cloud controllers are split out the Kubernetes core repository, and they are now managed by the community. And in this case, the community is pretty much Azure engineers. So this managed identity is crucial for the good operation of the cluster. And up till now, this credentials, this identity was limited to be a service principal. Now, service principals are great, and we use them a lot, of course, but they are hard to rotate. They are hard to maintain. There may be some creep in the scope of this service principal. So that's why the AKS engineering team came up with the idea of using also a new kind of authentication service that you knew by the time frame of Azure. I think we can assume is around a year or a bit more. Managed identity, they came out a bit more than a year ago. So managed identity are identities managed by Azure and assigned to specific resources, and that can be retrieved the resources at runtime. So AKS, since really this went GA last week, if I'm correct, so it's really new. It's been in preview for a while. So this avoids the use of service principals in your AKS cluster. So there was a big security hole in having all AKS clusters using this service principal in the form of a file on the file system of every node in AKS. And since you can use this enable managed identity flag when you create a cluster, you can let AKS talk to the underlying Azure host via the metadata service, which is, if you don't know, it's a service that runs everywhere in Azure. So every VM and VM scale set can access this information through HTTP call to a standard IP address, which is 169.254.169.254. The AKS nodes, the AKS can make a call to this service, retrieve a managed identity, use that managed identity to talk to the cloud provider. This makes things so much better and so much more secure that it's really a no-brainer to use it. And I wish this could be enabled by default, maybe in a future release of the CLI. Next to it, so you have a cluster up and running. If you don't enable Active Directory authentication, really you are limited to just to use authentication within the cluster. So in things that we need to establish is the difference between authorization and authentication. So authentication is assuring that you are who you claim to be. So is in Kubernetes delegated to authentication authority, in this case Azure Active Directory, but could be GitHub, could be anything really that supports the OIDC protocol. And authorization is establishing what can you do, what that identity that I now established you actually represent can do in the cluster. And that's the topic for role-based access control that comes right after this. So now focusing on the authentication part, Kubernetes really doesn't have any sophisticated user management strategy. It really, actually, Kubernetes really doesn't care or doesn't want to. Is a strategy adopted by the community that built Kubernetes in the first place. Really, Kubernetes doesn't want to manage the users. It wants to delegate user management to a third party. It's great because we do have one of the best user management platform in Azure, which is Active Directory, used by enterprises all over the world, incredibly secure, incredibly flexible, supports a lot of protocols, supports two-factor authentication, supports a bunch of security measures that really makes it the enterprise standard for authentication. So if you have a Kubernetes cluster, it costs you very little. It costs you basically nothing, or just creating a couple of applications in your Azure tenant to enable Active Directory authentication. So this way, everybody using the cluster, it will be identified by his own Active Directory identity. It's very simple, so it's a flow of authentication. Starts from the normal kubectl commands. Instead of retrieving what is called the admin credentials from Azure, you retrieve a generic credential that doesn't contain any certificate, any token, but simply redirects you to the OIDC authority, in this case Azure Active Directory, and then through the browser you can retrieve your token, which you can use to control to Azure. The flow is very simple. It's very seamless. It just lets everybody with an identity in Azure, and not everybody, of course, but you can also control who has access to Kubernetes. You can use groups as well, so you can put your developers in groups and then assign groups to the identity that can access Kubernetes, and let you authenticate users based on the Active Directory identity. It's really what you should do for every cluster, so you can let developers or administrators that live in different groups access your cluster very easily. Now, once you have authenticated people, authenticated your users, it's time for the authorization part. And that's where this is all done in Kubernetes. It's all done by means of role bindings and roles, which in the beginning, they are completely empty. So even if you have a user in Kubernetes, a user in Active Directory that can access your Kubernetes cluster, the roles are completely empty. He or she can't do anything on the cluster unless you assign a role, and you assign the role to the user through a role binding. So this is role-based access control 101 for Kubernetes, but it's something that people really don't simply overlook. So what happens is that we tend to give everybody too lax access to the cluster, in the sense it's too easy to just assign cluster admin roles to everybody, because it's just simple and it just works. But it's something that you really should avoid, and use specific roles for specific users. So if your developers need only access to a specific namespace, you should use role and just the role assigned to a namespace. Roles are namespace scoped, so called. So roles are a set of rules that allows specific verbs, list, get, create in this case, for example, but they can also be update or other verbs, to specific resources in a specific namespace. And the other way is to have a cluster role, which is exactly the same. So lists verbs that are possible on specific API resources, but in this case, they are not restricted to any namespace. So when you have a cluster role, you can do, for example, list pods, means that you can list pods in every namespace in the cluster. So be careful with cluster roles. Most of the time, your developers don't need cluster roles. They just need roles for the resources in their own namespace. I hope everybody's following so far. So next thing to consider, right? So we now have a cluster that is up and running and is only allowed to be accessed by a specific subset of our users. Now we still can do everything we want from the network perspective. So one of the rules in Kubernetes is that one of the 3 networking rules in Kubernetes, they're very simple. It's a simple networking model that Kubernetes adopted, but the basic tenant is the basic rules is that every pod can communicate with every other pod in the cluster without NAT and without any particular restriction. And every host can talk to any pod in the cluster, no matter where it sits, no matter which node it sits. So this makes it for a very simple networking model, but also quite the opposite from the security standpoint. So if every pod can talk to any pod, means that if I have a database, it's not protected from access from namespaces that don't belong to me. So many years ago, around many years ago, of course, in Kubernetes, years is probably about 2.5. A company called the Project Calico introduced what today is part of the core Kubernetes API, which are network policy. So network policies are, imagine, microsegmentation for your pods, for your containers. So it's basically a firewall that you can apply to objects in Kubernetes. And objects are not limited to pods, of course. So in the end, it's always about restricting what pod can receive or transmit in terms of the network traffic. But they are very powerful because you are not limited. You can specify labels. You can assign network policies to, for example, namespaces, and so you can just group together resources and assign a network policy to them all together. So it's extremely powerful and something that you really should implement. It's again just a flag that you can enable at the cluster creation. Unfortunately, you cannot modify it after cluster creation. So just learn these things, and when next time you create a cluster, just enable all these security features, because it makes your life easier and makes your security posture much better. So network policies are great. They work with both the basic networking and advanced networking. I use them a lot with Kubernetes as well. They work just fine. You can define label and namespace to apply them to. The crucial part to understand about network policies is that you should let your developers be able to create their own network policy, because they are the ones that understand their own application the best, and they know what their application requires from a network access point of view. So network policies are really part of your application now. They're not something that is imposed. Of course, there are some network policies you can impose on the cluster level, for example, with the global network policy rules. But it's something that developers should be able to decide for themselves if their application needs TCP access to a specific port or UDP access to another port. So it's really now this policy is part of the application deployment as well. For example, you can apply a policy to the whole cluster with global network policy. This is something that I always tend to apply to my own clusters, which denies access to the metadata service from every pod in the cluster, which means, so every pod in the cluster can actually make a call to that metadata service I was talking about when I was talking about managed identity, and just retrieve whatever is offered by the Azure host, the Azure underlying host, to the node is the same that can be retrieved by the pod. And you probably don't want that. It's a bit of a risk giving too much access to the pod. But pods, even unprivileged pods, can do this network call unless you apply this template and you make sure that no pod can do it. There's a great tool released not too long ago, which lets you visualize network policies, and I suggest you go and have a look. Audit logs. So no class is really secure if you don't know what's going on, and if you don't have alerts when something goes wrong or something happens that requires your attention. So audit logs are extremely important, something that really should be part of every production deployment, every production cluster. You probably can skip this for dev and test, but you really want to know if something happens when it happens, and at the moment it happens, not a day later or a week later. You want to know exactly what's going on, and you want to alert on audit logs. This is how you enable it. It's a setting on the resource group of the class of the cluster that is running, the resource group that contains the cluster. This is how it's done in Azure. Of course, there are many other ways to approach this. Of course, there are third-party tools, software as a service, log collection from Elastic CO. So there is this SaaS offering from Elastic. It now runs in Azure as well. But this is the Azure way, or at least what is your disposal without going shopping around for auditing audit logs. You have to enable it because the masters are running in a Azure infrastructure. So you need to tell Azure to actually export these logs to a log analytics workspace that you should have already there. But once you do that, it's just one query away. And this query is Custo language, which is KQL. So it's pretty new to me. I also don't really understand much of the syntax. I'm more used to other query languages, but it doesn't take too long, and there's a bunch of resources out there that can help you out finding out exactly the queries that you need. Watch out for costs. So these things, they log a lot. They are very verbose, so by default, if you leave everything by default, the retention time is, I think it's 15 days. So you may end up paying more money for your logs than for the actual cluster. So be careful with the running costs. Compliance. This is some question that people keep asking. So yes, Azure Kubernetes Service is complying with a bunch of actually with most of the security and compliance regulations. So PCI, ISO, IPA, they're all in there. So please keep in mind that the service is securing itself and it's part of the Azure offering. One thing that also is a recurring question: if AKS pass the CIS, Center for Internet Security tests, it does. There are a bunch of warnings, of course, so you can run it yourself. It's KubeBench. It's from AKS Security. It's a free job. Actually, it runs as a job in your Kubernetes cluster. You can just analyze the logs. You can see there a bunch of warnings, but the most important checks are valid. So yes, even if it runs, so nodes are running on Ubuntu 16.04. It's not a CIS hardened image, but it's totally passing the test of from the Kubernetes point of view. Image scanning also. So of course, like talking about security, you're only as secure as the weakest link in your infrastructure, right? So it's great that you have a very tightly secure cluster. You don't let anybody without Active Directory two-factor authentication flow. You are complying with all the standards out there, but yet if you let a foreign image, if you let some compromised image in your cluster, it's game over. That image may escalate privilege, it may get out of his own container or his own context and do something weird on your cluster. So it's important to shift security left. So this is what we intend by shifting security left. So starting at the very beginning from the source code control, and it's not mentioned here, but you can also scan your code for so using a static analysis tool for code, and then from that code that is being validated and vetted, build images, and then have those images scanned by a third-party tool like AKS Security, Twistlock, and nowadays Palo Alto acquired Twistlock, so it's now talking about Palo Alto solution, and Snyk is another very popular third-party tool, or New Vector. So you want to scan your images when they are pushed to the registry, because that's the first point of contact, is the bridge between Azure Container Registry and Kubernetes cluster. So what happens is that you can use this tool to both wait a second. Go away. I'm in a call. I'm in for work. Go. Okay, can you give me a second only?
Yeah, no problem. I think we will manage. This is the stuff that happens during these times, right?
Yeah. So sorry about that. So maybe we can cut it from the YouTube stream. Anyway, so so once you have the scanning of your images, then you can allow the AKS cluster to pull them and run them. So these tools usually they split into static image scanning and running image scanning. So running image is a continuous scanning of running containers in your cluster. Most of the time they use the operator model to do this, and they're very popular, and please shop around, have a look. We also have some solution in Azure Container Registry, but we rely on third party for most of the time for this. The OpenPolicyAgent is also getting extremely popular. It's an open source project is actually donated to, is part of the CNCF. So OPA as a open source project is part of the CNCF. Gatekeeper is a way to implement OPA, Open Policy Agent rules very easily in Kubernetes. And what it is, so what are these policy, what are these policies that we're talking about? So Kubernetes, the API server internally as a flow of API of every call. Every API call has to go through, of course, like the authorization, authentication. So we know who you are and what can you do. But then at some point, it's the admission controller. So the admission controller can enforce rules on the API calls, and the API calls in Kubernetes are of all sorts, right? So you may create a pod with an API call. You can create a namespace or do some operation in your cluster, create, destroy, create, delete, update resources. So every single one of these API call, when you implement things like the OpenPolicyAgent through Gatekeeper, for example, they go through this admission controller, and they don't pass the admission. They are basically blocked, and they are not allowed to continue and to actually be persisted. And for example, the resource they create, it won't be created. So the Gatekeeper project is really a way to make it easy to implement OpenPolicyAgent rules, which is normally written in, it's not a weird language, but it's something called the Rego language. It kind of looks like Go, but it's really a bit complicated. So what the Gatekeeper introduced is a bunch of custom resource definitions. So for example, require labels or whitelisted registry, that they make it simple what is kind of complicated to do in the Rego language. So for example, whitelisted registry is also quite a popular demand. It's something that you probably want to implement your own cluster. So whitelisting registry that are allowed to provide images to the cluster. So if you implement the policy on the left, basically the cluster will not be allowed any request like pod creation. In this case, kind is pod. So every pod that has a parameter registry that is not part of this list. So, and in this list, notably absent is the Docker registry, app.docker.io. If the API call is not
Alessandro, we have a question.
Sure.
Is the OpenPolicyAgent integrated in Azure Policy as well?
Yes. So Azure Policy is also in preview. So to implement, to manage and enforce these policies across multiple clusters in Azure. So this is an open source project. You can just deploy it everywhere you want, but in Azure you have this extra gear of being able to manage these policies and apply them to multiple clusters at the same time, enforcing them all across your infrastructure with the click of a button or API call or whatever. So I don't know if other cloud providers are planning to do that, but it's definitely something that in Azure makes it's easier, because in a way also this project came not only from Microsoft, of course, but lots of Microsoft engineers contributed to this, so they make it easy to integrate with Azure. Any question? It's a big project. It's getting a lot of traction. In the unfortunately now cancelled KubeCon Amsterdam, there were a bunch of talks about Gatekeeper. The version 3 is coming out. It's actually probably already out. You can test it out, and it's a bit complex to implement, but as anything in the beginning is a bit complicated, but then it gets easier as more people and a bigger community gathers around. Okay, so now that we have a secure cluster, sometimes our workloads, sometimes we want to use pods. So pods are running our application. Sometimes our application needs to interact with Azure, with our cloud. So the trick here is to allow secure access to Azure resources to pods. And it's not an easy task, but the Active Directory pod identity, AD pod identity, is an open source project as well, kind of came with this mechanism to allow pods to retrieve identities and use those identities to access Azure. So is a controller. So this controller watches for Azure Identity Binding, which is is a CRD, is a custom resource definition, is an object that you can define that basically binds a pod identity, an identity to a pod using labels. So every pod with that label will be able to access specific identities. So the Kubernetes controller watches this for this object to be created. When there's an object of this kind, creates the route for the pod to be able to access the metadata service and retrieve the token. With that token, the pod, the application inside the pod, can use it to access Azure, and it's standard access to Azure. So if you have a .NET application, you can use the standard .NET SDK for Azure, get the token, and use it to create or retrieve resources from Azure. So it's not for it's a very interesting project. Makes it easy to integrate application with Azure. So to make like what is called a cloud native application. So this is an important step, an important piece of the puzzle of the pitch that makes Kubernetes a first party, first citizen in Azure. Now, another question that comes often from customers, okay, I have all this great application running Kubernetes, but I'm sick and tired of writing down secrets in YAML. I want to have a secure store for all my, for example, connection string, for all my database passwords or whatnot. So, and this is something that has plagued Kubernetes for a while. So secrets in Kubernetes are indeed like secrets, as in they have their own API, but being just encoded base64, they are not really, they don't offer any encryption at rest, or they don't offer enough protection from unwanted eyes. What we want to do instead is to use a proper secret store, like Key Vault in Azure, and expose those secrets to the volumes as they need. So this is another great open source project. Is Key Vault FlexVol. So FlexVol, it's a mechanism in Kubernetes to mount file systems, virtual file systems. So flex volumes are of different kinds. So there are many drivers for FlexVol. There was a FlexVol driver for Azure Blob that lets you mount blobs from Azure as block devices inside a pod. So there was a very popular. It's not used that much anymore, but it was one example of using FlexVols. In this case, the FlexVol driver is Azure/KV, as in Key Vault. So it means that they can take a Key Vault secret and mount it as a volume inside the pod. So how does it work is a bit complicated. We're not gonna explain in details, but what you want to focus on is that you can use different options to allow that pod that use this volume to access the Key Vault. So for example, the easiest one, but also the less secure in a way, is to use service principal. But again, that's kind of a chicken and egg problem. So that service principal has to be provided to to the flex wall to this pod as a Kubernetes secret. So it's not exactly the best way to do it. You can use the pod identity, the project we just saw before, to actually provide the pod with an identity, and then out of band, out of the cluster, you map that identity to an access policy to the key vault, or you can use VM bound identity. So nodes, of course, can have identity. So the nodes where these pods running, they can have identity, and then the pod can use that identity to access the key vault. But you have to be careful. For example, you can have a VM scale set, a pool that have an identity, and you can schedule pods that needs to access that secret key vault only on the specific pool that needs to access the key vault. It's a bit complicated. I'm not gonna dive deep too much. It may require an entire new hour, but it's very powerful and lets you store secrets in key vault and access them from pods. That's the gist of it. That's also something that it's pretty interesting to enable on any cluster. So clusters are composed of master and workers, of course. The masters run in the Azure infrastructure. Masters have public IP access. I mean, everybody, they are exposed to the whole internet without particular precaution on which IP address can access it. Unless you do enable it on your cluster. Again, you have to enable it at the creation of the cluster, but it's basically a firewall that allows you and only the cluster access that the control plane. Very simple. You can actually update the API server authorized IP range after the creation, because you can add your own IP if you like. So that's quite a powerful feature. So it's not a fully fledged private cluster, which I'm going to talk in a moment. But it's already pretty good security prevention from unauthorized access to the control plane.
We have a couple of questions again.
Yeah.
One from Girish. Can we just use managed identity to get secrets from Key Vault?
Yeah. So you can have managed identity, assign that managed identity through the pod identity to the pod, and then the pod can mount using flexible the Key Vault secret. So when the pod mounts it, it becomes either a file on the file system or an environment variable. That's basic Kubernetes approach to both config maps and secrets. So it's very, very flexible in that regard.
Yeah, and another question by Madhu. What's the difference between using FlexVol or Key Vault controller and WNV injector?
WNV injector?
Yeah.
I don't know what is WNV injector. WNV injector? I don't really understand.
Okay, there's a bit of delay, so let's just continue. And Madhu, if you hear this and you want to explain a bit further your question, then I'll ask it again to Alessandro. Please continue.
So I'm not gonna spend a lot of time on private clusters. They're great. So since a couple of weeks, we do have custom UDR, user-defined route on clusters. So this is the first iteration of a private cluster. So having a firewall between your cluster and the outside world, and then managing the egress and ingress through the firewall. That's great because you can literally monitor and make sure that your application is only able to talk to a specific host. So you have to allow some domains because they are needed at, for example, to the good functioning of the underlying Ubuntu OS, for example. But it lets you be very flexible with this. There's also a great blog post from my colleague Dennis it's so complicated. I would spend so much time on it, but the gist of it is that it lets you have a completely private cluster with no public IP whatsoever, no public IP on the control plane, so fully private access to the control plane from the cluster. This with a new feature in Azure called Private Link. You can peer your on-premise networks to the AKS cluster network, and you can have private DNS zone that can also resolve from the on-premise network to the AKS cluster. So it's completely possible to have a totally air-gapped AKS cluster in Azure, fully managed, of course, and that has completely private access, for example, to SQL servers with service endpoints. So it's a whole story. I only have 15 minutes left, so I want to go through quickly. Workload isolation is also an interesting.
So let's quickly come back to the question. It was a typo. So what's the difference between FlexVol and the Key Vault controller and environment injector?
So maybe you are referring to the new CSI driver for Key Vault. So I intentionally left it out. So there's a new driver. So this FlexVol thing has been in service for a while and it works pretty well. But there's a new paradigm in storage for Kubernetes, which is the container storage interface. And there's a new project working on integrating CSI. And it basically does the same thing, but with a more modern approach and a better integration. I'll leave it out for now, but we can come back and we can come to the Slack channel and we can continue the conversation.
Okay, it was a good question, at least from him. So please continue.
Yeah, that's so the workload isolation is an interesting question. It's also something that keeps coming back. So how should I use single cluster or multiple clusters with multiple pools? What is the best approach? So since a few months, we have node pools in Kubernetes in AKS, which means you can have multiple node pools in the same cluster, managed by the same control plane, but dedicated to different purposes. And every pool will have its own, for example, VM size. So you can have a pool with NVIDIA cars in it, and a pool with confidential computing, or a pool with spot instances, which is the instances in Azure that are meant to be ephemeral, so that they might go away at any given time. And that's all right, because that pool, you dedicate that pool to non-crucial workloads. So that's also, it's part of security because it's part of business continuity. You want to make sure that the pools are also spread over multiple zones. You want to make sure that you have multiple pools to be able to update them in sequence, or not being stuck with just a single pool that you have to upgrade all at once. But you can have multiple. You can spread your application over multiple pools as well. What we really suggest in this case, of course, it's great to have multiple pools. It's great to segregate application on different nodes and node pools, but always dedicate a cluster just for production, and everything else can go on the same cluster, separated by namespaces, separated by segregated in node pools. But the production cluster should be separated, physically separated from everything else, with its own access rules, its own possibly role-based access control rules, connected to different, for example, Active Directory groups mapped to those cluster roles. So it's important to keep the distinction, keep the production workloads on a separate physical cluster. Host and cluster security. So what does it gain to us if we have a cluster that is working great, but then we are not, it doesn't get security patches and security updates? So for this, worry not, AKS allows you to, AKS is set to automatically apply all the OS updates. In this case, we're talking about Ubuntu, so this is updates that come from canonical. So say that is a 0-day, it doesn't happen very often, but there's a 0-day Ubuntu CVE out there. What happens is that every night at 6 o'clock in the morning, actually 6 o'clock in the morning most of the time, at least the way I see it, maybe it's probably midnight somewhere in America, the cluster, the nodes apply apt-get update. Basically, the apt-get update, of course, is only restricted to security updates. So all non-crucial, non-security updates update packages, they don't get installed, so you don't get an update for less crucial packages, but you get everything that is deemed as security by the canonical engineers. So this happens every day, and you are sure that you are running patched servers every day. There's one caveat, which is some updates, they do require rebooting of the nodes, for example, kernel updates, and they are not nodes are not rebooted by Azure because we don't want to interfere with your workloads. But you can set a daemon called cured or curd to automatically reboot those nodes in a staggered fashion. So one, you don't, the daemon makes sure that the nodes are rebooted one at a time, and no more than one node is down per update process, per update schedule. So it's simple to install, just one Helm chart or a template, and you should really make sure that you have this in place. And regularly update your class. If we release new versions once in a while, I suggest you that you watch the github.com/azure/AKS releases. So you get a notification every time we release a new version of AKS, and keep your cluster updated. Upgrading is only one API call away. It's completely non-destructive and zero downtime if you have multiple pools and if you have multiple nodes in your clusters. But you should really be able to do this on a Monday afternoon when everybody's crazy about uptime. And if you should do this often and make sure that things keep working as expected. We support 3 versions of Kubernetes. So if you can see, so the one that is up now is 1.16, and we still don't bother you if you run 1.13, but you know that you have about a year because Kubernetes is released every 3 months, and this is about 9 to 12 months away. Azure Security Center is a service in Azure. It will scan all your registries and will tell you which images need remediation. It will tell you remediation you can apply to your cluster. So this cluster has 2. One of them is because there is no security policies. I'll talk about it in a moment if I have enough time. But it's there's a free tier and a paid tier. This from this free tier, so it will want. It doesn't have the full feature of the paid subscription, but it's good enough to have an understanding of what's going on. And it constantly monitors your cluster, constantly monitors your registry for new images uploaded and new images for that contain flows. Now, last topic, so maybe I'll be in time. So GitOps and security. So GitOps is a paradigm of how to deploy your cluster, the application that runs in the cluster, in a completely automated way. So it's different from the classical CI/CD where you push code to your tooling of choice, Jenkins, Azure DevOps, that builds an image and then push that image to a cluster, but this relies on a what is called Flux controller that sits in the cluster and monitors Git repository for changes and applies those changes in the cluster. So you keep your configuration of everything that should run in the cluster in Git. You push to Git, and then you are confident that your clusters are auto configuring based on whatever you push to that Git repository. So it's not an apply, it's more of a pooling of configuration. It's a new way of managing clusters. It's very popular, been adopted by, it's been started at WeWorks, but it's been a popular concept in Kubernetes in the last year or so. We adopted it for, of course, also it makes easy to also manage secrets in Kubernetes. There's a thing called seal secret controller. Make sure that you can push secrets to GitHub or to Git. They are not really the secrets. They're a thing called seal secret. So it's a representation of that secret encrypted with a public key, and being the private key being only owned in the cluster, make sure that the cluster is the only entity that can decrypt that secret inside the cluster. So you can safely expose your seal secrets to the internet, to Git, because you are sure that the Kubernetes cluster is the only one that can actually translate that into a secret that can then be exposed to the workloads. Now we use this GitOps idea in this new preview service, which is Azure Arc, which is an extension of the Azure management control plane to on-premise, multi-cloud, edge. So their Arc is also a very complex product, is in preview, so you're gonna hear about it a lot more in the coming months. There is one particular thing, which is the Kubernetes Arc for Kubernetes, which allows you to adopt Kubernetes clusters from other clouds, or running on the edge, running on Azure Stack, running on your on-premise, and make them part of the Azure infrastructure. So so you you can manage those Kubernetes clusters through GitOps automatically through the Azure portal or the Azure management control plane. So it's centrally managed. You can control configuration and workloads at scale. So one single policy for all your clusters. Use the GitOps model, so you don't need to push anywhere, but your cluster will apply the changes. The advantage is that managing cluster configuration via GitOps makes it auditable, makes it secure, because of course it relies on the Git infrastructure to secure code, and just make it easier. So, and then of course you can bring this to every cluster, on-premise, edge, and wherever. So this was my last topic as well. I have 4 more tips to share with you. It's so simple. Don't use Elm version 2 anymore. That's it. Use Elm version 3, because Tiller used to be, Tiller was the server-side component of Elm. It was complicated to secure, so people just let it run with cluster admin credential, and that's really not a great idea. But since Elm 3 gets rid of Tiller, just relies on your own credential to create resources in Azure, there's no reason not to use Elm v3 anymore. Remove the Kubernetes dashboard. So there's no need to leave the dashboard around anymore. It's really not a great dashboard, by the way. You can disable it because it's kind of an add-on. You can disable. I wish this was part of the creation command, but it's something you have to do after the fact. Terraform actually lets you disable it when you create a cluster. And there are alternatives, Octant and Lens. Lens has been open source recently, and Octant is completely client-side. Both of them are completely client-side. You don't need to install anything on your cluster. If you have a kubectl, if you have a kubeconfig that can access that cluster, you can manage it with a nice dashboard as well. Third tip: don't even give any SSH key to your host. So the -X flag basically skips the whole SSH key injection inside the host. So in a way, you are not allowed. You have no way to to access those nodes anymore through the normal meaning. Those nodes don't have public IPs anyway, but if you are particularly inclined to, you can access them through a Bastion host. But you should not access host anyway. But if you really need to, you can use ncenter, and I have a handy quick handy gist for you. Last, rotate service principal, but even better yet, use manager identities, as I explained to you in the very first topic. Another one, the fifth one, extra one, forget pod security policy. Pod security policy is not on the way out, but it's very complicated to implement, and you can do almost everything that you want to do with pod security policy with Gatekeeper plus OPA. So if you want to restrict access to the cluster, or you want to whitelist Docker registry, that's the way to go. Gatekeeper and OPA is the future of enforcing rules and policies in any cluster. Some references, the security and governance workshop, more resources to learn Kubernetes. We have the learning path is 30 days of learning Kubernetes. And that was it, right on time. Please join the meetup. Unfortunately, we are on a hiatus, so we are not organizing any in-person meetups for the time being. Also, the conference, we're gonna postpone it. It's not gonna be in September anymore, probably more like March or April. Some decision you have to take. There's no way around it. It's the way it is. But we can still meet virtually on the NL user channel on the Kubernetes Slack. So you can get an invite if you go to slack.katest.io. And that's it. So any questions? I can stay around for 5 more minutes. So.
Yeah, well, first of all, thank you very much, Alessandro. There was quite a lot of new information. And we're back. So, okay. That was weird. Yeah, it was Skype kicking us all out. So, with that, I think, what the people didn't hear because the Skype was killed, I was thanking Alessandro very much for this session. It was a really good session, really in-depth knowledge about Kubernetes security. When we spoke last week, Alessandro said, well, only 30 minutes, let's keep it short. And now he was starting to talk. I was like, okay, 16 topics, that's going to be really fast. But it's really, really good knowledge. And good thing of having this online is that people can watch it back in their own time. Take a look at the different topics when they want to explore a bit deeper. And go on to the Kubernetes Slack if you have further questions on the NL users channel. So I think that's a good pointer. And overall, I had a great time and hope everyone had a great time. This was the 10th episode of Azure Community Live, so it's still early days, but it's really cool to have 10 episodes already. So thanks everyone for subscribing, for watching, for liking all these sessions. And well, we're still looking for future speakers as well. So if anyone has a great topic they want to hear and talk about, or if you know someone else who wants to do a session, send them to us and we'll make this happen. We have some sessions coming up in the near future, some about application insights, some about GitHub Actions for Azure. So we'll post those dates soon as we have set the date, and then we'll keep you up to date. So subscribe to the channel to get these kind of updates, and hope to see you all in the future soon. Oh, Alessandro, some people are asking for the slides. Will you send them on Twitter as well?
Yes, I'll do it on Twitter. Yes.
Okay. Well, thanks everyone, and well, we'll leave it with that, and see you all next time. Bye bye.
Thank you. Bye.